Welcome to LabMinutes.com. In this video, we will look at Next Hop Resolution Protocol, or NHRP. NHRP is probably one of the less well-known protocol, and most of the time it will not be used by itself. However, NHRP is actually a basis of another more popular technology called DMVPN, and DMVPN is basically an NHRP with an added component of IPSec. The main benefit of NHRP is its multi-point capability, where you can have many or multiple spokes connect to the hub, where you can just use the single tunnel at the hub, and then the spoke can also dynamically build a spoke-to-spoke direct tunnel. This basically eliminates the need for the hub to have individual tunnel interface configured per spoke. NHRP as of today has three phases. So phase 1, which is the original phase, just support a hub-to-spoke topology, and then phase 2 support the spoke-to-spoke topology, and then phase 3 that recently came out support enhanced spoke-to-spoke, and support added features such as the hierarchical topology, and then allow the spoke between different regions to build a direct spoke-to-spoke tunnel, and it also allows you to do a route summarization at the hop level, which we will see how that works in this lab. If you look at our lab topology, here we have 5 routers that we are dealing with. They got router 1 through 5, and then the physical topology is just connected to a switch that has the routed ports configured, so they will be just basically 2 hops away from each other. But the logical topology that we will look at is going to have 2 hubs, R1 and R2, and then we will have 3 spokes. R4, R3, and R5. Our goals for the lab is to build a dynamic spoke-to-spoke tunnel from R4 to R5 through the router R3. Okay. So let's start our configuration. Let me adjust my screen for a bit so you can see better. Okay. Let's start off with a router R1, which is our hub. Actually, before we do anything, let's set up Wireshark. So we're going to be spanning the router 4 physical port. So we're going to set up Wireshark so we can see the NHRP packets that we can look at later. Okay. Okay, so start up R1. The first thing you would do is configure a tunnel interface, TU1, and give an IP 1.1, subnet mask of /24. Okay, then we'll do IP NHRP just to show you different options that we have. But the first command that we would do is a network ID, so we need to give a network ID, and you can see the network ID number can get very large. So here we're just going to do 1. Next we're going to do map. Since this is the hub, we're going to do map multicast dynamic. Let's do NHRP authentication. Just going to give the word Cisco. We're going to do NP IP NHRP. The next is going to be hold time. Hold time is basically how long the advertisement is going to stay valid for. And if you lose the spoke, then the mapping will be deleted when the hold time expired. Here the hold time is number of seconds. We're just going to do low enough so we can see when it expired. So just going to do 10 seconds. Although this might be too low when you're trying to use this in production. Next we'll do IP NHRP registration. and timeout, and this is how often a spoke send a registration request to the hub. Again, we're going to keep this value low so we can see when we try to capture it. So here we're just going to do 3 seconds. Okay, that should be it for the NHRP config for the hub right now. Next, we're going to turn into the tunnel command. First, we'll give it a key. So each tunnel needs a unique key in the same file. So here we're going to use the key 1 for this. And we're going to give it a source. And here we use fast Ethernet 00 for the physical interface. And then the key command is tunnel mode GRE and multi-point. Okay, by default it would be IP, and that's what you normally do for point-to-point, but here we'll do multi-point. Here we're just going to add keep alive, so that the two end of the tunnels can do a keep alive check and bring the tunnel stats down when it no longer detects each other. Okay, so look at our config. Not too bad for the hub. Okay, next we're going to enable routing, and we're going to choose EAGRP, autonomous number 1, and then no auto. As default, and then we're going to do no passive on our tunnel 1, and then we will add network command. Okay. Just to confirm, our tunnel 1 is now enabled with EAGRP. Okay, so that's it for R1. Next we're going to jump to R4, which is our first spoke. Let's see if we can copy some of the config that we did already. Give me 1 second, let me bring up my notepad. Okay, for the most part, let's separate that. Address here is going to be 1.4. And authentication Cisco, let's move that out for now. Then network ID 1, hold time 10, register 3. So we're going to start off with that. We're just going to, wrong router. So let me correct that back. That should be 1. Okay, everything else should be the same. Okay, router 4. Okay, since this is a spoke, the command will be slightly different. We have to tell it the location of the hub. So the first command is map, and here you can see the IP address of the destination, and that's actually refers to the tunnel interface, although it should say tunnel to be a little more less ambiguous. And then the NBMA address in this case refers to the physical IP address. So the physical IP address for the hub or R1 is 4.1. Okay. Then we're going to do the map for multicast. And we're going to tell it, since this is not a really full multicast supported network, it's an emulated in the sense that it's a non-broadcast multi-access network. So we need to let it know if there's a multicast packet, where should it send to? So again, we're going to point it to the hub. And then we're going to tell it the next hop server, NHS, is the, let's see what it said. Again, IP address of NHS, and that's just a tunnel IP. Now, we still have a tunnel commands to do, so keep alive. All these should stay the same. Okay. Then we're gonna do, so router NHRP1, so we can copy to our next tab. Spoke. Default no pass channel 1 network 192.168.1.4 in this case for router 4. And then we also have a loopback 0 that we use to emulate the subnets that we would use for our tests. Okay, so copy that. And you can see the adjacency has formed. If you look at the tunnel, it's showing states up. And I should be able to ping the tunnel IP of the hub, which I could. Okay, let's leave it at this for now. We'll come back and look at some show commands when we complete the rest of the configuration. So now we go to router 2. Router 2 will be very much similar to router 1 with a few modification here. So tunnel 1. Again, I'm doing this just so that we can get our configuration completed faster. Okay, so for R2, that will become tunnel number 2 with IP address 2.1. Leave everything else. Network ID, we're going to change that to 2 as well. Same hold time, same registration timeout. Same keep alive. So R2, paste. Now on R3, R3 actually has 2 tunnels, one on the cloud 1 and one for the cloud number 2. So for R3, we're going to have tunnel 1, 1.3, network ID still 1, everything else stays the same. Oh, actually, let's grab the config from R4. Let's do that again real quick. Okay, tunnel 1, that would be 1.3. Everything else stays the same. And then you have tunnel 2 with 2.3. And the tunnel IPs of cloud number 2 of the hub is 2.1 with the IP of 4.5. That would be 4.5, 1, and that would be 2.1, network ID 2. Actually, everything else just stays the same. We're going to update our tunnel key as well. That's one thing we did not do up here. So that would be tunnel key 2. So the R3 doesn't get confused when you have 2 tunnel interfaces configured that's sharing the physical interface. So let's update that. It's tunnel key 2. So that's tunnel key 2. Everything looks good. Okay, I'm just gonna make a minor adjustment with tunnel 2, and then add the network. That should be 1.3 and 2.3. Okay, so that should be it. So let's copy and paste all these. for our spoke R3. Okay, and here we have our adjacency on the first cloud up. Let's see what's happening with the second cloud. Let's make sure the R3 can ping R2, and yes it can. Let's see, what are we missing out here? 4.5, 4.5, 2.1. Oh, we actually don't need that. So clean it up real quick. Oh, looks like we did not do the NHRP config for R2, so yep, has not been completed, so we're going to copy R2 only has tunnel 2, the network of 2.1. Okay. Paste. And now the adjacency has come up. Okay, on R3 we have 2 NHRP neighbors. So all's good. Now we gonna have to complete R5. Which, let's just delete that. And for R5 is 2.5. Everything else stays the same. You can see how it's very easy once you have a template to bring up a spoke, since it would look almost identical as far as the configuration goes. Okay. Okay, tunnel 2 is up. Oh, and I did not update the IP 2.5. And here's our neighbor. And on the R5, we also have a loopback 0 to emulate the spoke network. Okay, just going to add that. Okay. Okay. Although you can see that we have a NHRP adjacency forms everywhere. Let's check some routes. So R1 is receiving the subnet 44 from R4. But if you look at R3, R3's got nothing. And this is because by default, the hub tunnel interface has the split horizon turned on, which prevents whatever route is being learned from spoke to be advertised back out the same tunnel interface to the other spokes. So what we have to do here is go to R1, you can do no IP split horizon, NHRP1, and we do the exact same thing on R2, tunnel 2, and now you can see the NHRP kind of refresh a little bit there, and now on R5 you can see the R4 loopback subnet has been propagated all the way across to R5. and the next hop is being 2.1, which is the hub IP. So from R2, if we ping 172.16.55.1, sourcing from loopback, so you can successfully ping now. If you trace, and you can see it takes multiple hops to get there. 192.168.11.13.21, and then goes to the 2.5. So it takes go R4, R1, R3, R2, and eventually reach R5. So every single packet has to traverse through the hop right now. So that basically completes our phase 1, or hop and spoke topology. Before we move on, let's take a quick look at how the NHRP is working. So let's look at our Wireshark capture. It seems to be seeing a lot of packets, so let's see if I'm looking at the right interface here. On the switch. There you go. So now I can see some NHRP packets, request, reply. So let's stop that. And 13 is being R4, and 1 is being R1. So let's take a look at the packet. We've got IP header, and then you can see the NHRP is actually wrapped inside a GRE header. And for GRE, you can see it's protocol GRE with the hex of 2F. So let's bring out my calculator. Programmer hex 2F. And if you would guess, it's protocol number 47. Okay. With the source, using the physical IPs of the router 4, which is 4.13, and destination 4.1. You can see it's kind of a repeat. Let's see. GRE, and then inside the NHRP payload itself, there's actually a lot of information in here. Got header, mandatory part, and here's the information that we are looking for, the source, NBMA address, which is the physical address, is 4.13. And then the tunnel address is 1.4. So here you go, there's your mapping. And the destination that's sent to, which is the NHS or next hop server, is 1.1. So if you look at router 1, show IP NHRP, here you see we have the router 4 registered. So the hub takes all these information and put them in the mapping table, and let's just map the logical or tunnel IP address to the physical address. And the same goes for the router 3. Okay, and let's take a quick look at the registration reply. It's pretty much looks very similar to the request. So there's nothing significant there. Okay, and if you look at the how frequent we see the registration request, the first time is about 7 seconds and then 10 seconds. So the configuration that we put for registration timeout, actually on R4, we use the same value. So it tells it to advertise every 3 seconds. Okay. Alright, let me look at the time real quick. Now we are 25 minutes into our video. I think I might split this video into 2 parts. So we just completed phase 1. I will create a separate video for phase 2 and 3, so look for that. Let's see if there's a few more things that we can look at here. So R4, that's a static mapping. It says right here, and that's when we do the map command up here. As opposed to R1, it's a dynamic mapping. And R2 should say something very similar. Yes, dynamic. And R5 is static. Okay, so let's continue with our phase 2 and 3 in our next video. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.